Let us see how it behaves. That is, it is the theoretical probability distribution for our continuous variable, or we can say it is the approximation of the binomial distribution. It is the case when P and Q both are approximately or nearly equal to each other, then the binomial distribution curve and the normal distribution curves, they behaves in the same manner. So we can say the normal distribution, it is the limiting case, also the limiting case of the binomial distribution. For the binomial distribution, normal distribution, here is the Px is equal to 1 upon sigma under root 2 pi. Sigma is the variance into e raised to the power minus half into x minus mu upon z divided by 2. Here x is the random variable, mu is the average, and z is the standard normal variable. It means in this problem we will have to convert our simple random variable into the standard normal variables, because to calculate the values of the curve we will have to check the results from the given tables. There may be the two options. If the table for the values of the normal curve available, it is less than 0.5 or it is greater than 0.5. Here we shall discuss the table for less than 0.5. It may also be greater than 0.5. So we call z is equal to mu upon sigma. That is the standard deviation. Let us say let z is equal to x minus mu upon sigma. X is the value of this standard normal variable, mu is the average, n is the standard, sigma is standard deviation, mu is equal to mean, and z is equal to standard normal variable, or which simply denoted by Sn. Before solving the problems for the standard normal variables, we will have to keep in mind some results. Say, number 1, if P, Z lies between A and B, that means P, Z is less than B minus P, Z is less than A, or if we take its value f of b minus f of a, it means we have taken the values from the table, or it will be provided in the problem. Number 2, if P Z is equal to P minus Z, if the normal variable is minus, we cannot check these values from the table. That's we convert it into 1 minus P into Z. Third rule for P, Z greater than or equal to A. Just I told previously the table, here we shall discuss according to our IGNOU booklets. Our normal variable values are given, they are less than 0.5. So we will not get this value from that table, and we will have to convert it into like this: 1 minus P, Z less than or equal to A. It is the third result, or we say the options. With the help of these results, we can solve the standard normal variable problems. First we should see the simple problems that say, find number 1, P Z lies between 0.87 and 1.28, and that is equal to, we apply the first rule, P Z less than 1.28 minus P Z less than 0.87, that is equal to f of 1.28 minus f of 0.87. We can check these values from the standard normal variable curve in this way. 1.28. 1 will be on the vertical column and 1.2. Here it is 1.2. We shall get 1, 2, 3 and so on up to 8. We check the value of 1.2 under the value 8. Here we will get 1.28, and for 0.87 we started with 0.0, 0.1, 0.2, 0.3. Somewhere here we shall see it is 0.8, and if we move towards the right, it is below 7. We shall get the value for 0.87, and that is equal to 0.8997 minus 0.8078, that is equal to 0.0919. It is a simple application. We have directly given the standard normal variation. Let us change some conditions here. Minus 0.34 lies between, Z lies between, that is 0.62. First we use the first results. We say P Z is less than 0.62 minus P Z less than 0.34, that is equal to P Z less than 0.62 minus, we cannot check the value of the minus, we shall convert into P, 1 minus P Z Z less than 0.34, or if we take the values from the table, f 0.62 minus 1 minus f 0.34, that is equal to 0.62. We will see somewhere here 0.6 on the vertical column and 2 on the right hand side this, and here we will get 0.62, that is equal to 0.7324 minus 1 minus 0.6331, and final result is 0.3655. Third option, we may have P Z greater than or equal to 0.85. As I told, we cannot check these values from the table which we are discussing, whose values are where Z is less than or equal to 8. We can convert it into like this, P1 minus P Z less than equal to 0.5, and easily we get the values from the table, f of 0.85, that is equal to 1 minus 0.8023, that is equal to 0.1977. So we compile all the results and discuss some problem like this. P Z greater than or equal to minus 0.65. First of all, the problem is greater than. We shall use this result, that P 1 minus P Z less than equal to minus 0.5. 1 minus, here again we will have to convert this minus, it is 1 minus P Z less than equal to 0.65, that is equal to 1 minus 1 plus f of 0.65, that cancels, that is equal to 0.7422. It is a simple results based upon the standard normal variable. Now let us see few word problems or the statement problems based upon standard normal variable. That is, now these values, just I introduced about the values. These values, they are always calculated by using the normal curve. In spite of we make the curve in every problem, then evaluated that all ancient mathematicians, they have provided all the values in the form of the table, from where we can see them or we can check them very easily.